Hello everyone, my name is Rohit Singhal and we were discussing about hydrocarbons. In the previous class we discussed about its importance in our daily life, its broad classification into the saturated and unsaturated hydrocarbons. Also we have briefly discussed about the saturated hydrocarbons that are alkenes. Now in this class we are going to discuss about the unsaturated hydrocarbons and see what are they. So, unsaturated hydrocarbons. Saturated hydrocarbons, we know there was a one C single bond C. Here it is of three types. One is alkene, the another one is alkyne, and then is aromatic hydrocarbons. Alkene, so do specify on this alkene, wine, and aromatic. Alkene means there is C single bond C, and there means and as I already discussed in the previous class, the carbon is a tetravalent compound and need to have 4 bonds. So, 2 bonds it have already made with the carbon, and the remaining 2 will be satisfied by the hydrogens. Alkyne means there is a C triple bond C, means 3 bonds with the other carbon, and there is one valency remain that is satisfied with the hydrogen atoms. Aromatic carbons, aromatic, this is a special class. A special class of hydrocarbons. How it is so? Let's take an example of this, then we will better be able to discuss what I am talking about. This is a benzene molecule, it's known as benzene. Its formula is C6H6. Okay. So, what is special about this? There is a C double bond C. Here is also the C double bond C, but what is there? It's an conjugation. It's an pi to pi. It's pi it's pi sigma alternate bonds present. Alternate bonds. What I am saying in this, see, this is a pi bond, right? This is a sigma bond, a pi bond, a sigma bond, a pi bond, a sigma bond. Means in the entire ring there is the alternate of pi and sigma bonds. So, this makes special about this ring. What is the second point? There is a pi conjugation. This is a pi conjugation. There is a pi conjugation in the entire ring. That means it can also be like this, means the double bonds are present in these positions, or where there are sigma bonds. Here was a pi bond, let us take the sigma bond, pi bond, sigma bond, pi bond, means the positions of pi and sigma bonds are swapped in two structures. Okay. So, this makes this this class of the hydrocarbons as a special class. Do also focus on this one. There is a pi conjugation in the entire ring. For example, let us take this molecule. Okay. There is no pi to pi conjugation, it is a normal alkene, a cyclic alkene. And if we talk about this there is a pi to pi conjugation, but it is only into this area, this alternate pi to pi, alternate pi sigma bonds. present. Yeah, they are present, but not in the entire ring. See, there is a sigma bond, this is a sigma bond, this is a sigma bond. So, there is no alternate pi sigma bonds in the entire ring. A portion of ring only contains the alternative bonds. So, this is not the aromatic compounds, these are normal alkenes. Okay. So, this we have okay. Now, let us discuss okay, we were discussing about aromatic, right, aromatic compounds. Okay. So, we have discussed example, we do not have to discuss much about this right now. Benzene we have discussed, this molecule formed by C6H6 and this is the structure, or we can also say this is the structure. Alternative pi bonds we have to make. Okay. So, let us go to another class of unsaturated compounds, that is alkene. Alkene we have discussed what it is. There is a carbon carbon double bond and there is one hydrogen here, one hydrogen here, one hydrogen here, one hydrogen here, and this is known as ethane. As we have as the name suggests of this class, this is alkene and this also ends with alkene. We have the previous class we have discussed is alkane, CH4. This is an alkane and this name is methane. So, it is easy to remember that whatever ends whatever the name of the series ends with, it is the name of the class, name of the members of the list also end with the same thing, ANE, ANE, and this ENE and ends with an ENE. So, these are ethene molecule. In alkanes we have studied starting with the methane and further on. So, there is, so the list starts from one carbon, but while in alkane this is the first member, this is the first member of the series. Starting with 2 carbons. Why there can be one carbon alkene as there was in an alkane? Because alkane requires a C double bond C. So, minimum carbon chain is of 2. Here it can be formed through one carbon, but here at least 2 carbons are needed to form an alkene moiety. Okay. So, as we discussed in the previous class about the structure of alkenes, let us discuss about the structure of alkenes. Let us discuss with this. Okay, I have told carbon has a 1s and 3 p orbitals, hydrogen has 1s orbital. Okay. So, this is the carbon. Okay, if I have to make a sigma bond, it will be like this, carbon carbon sigma bond. Okay. So, this is a sigma overlap and giving a sigma bond, strong sigma bond. Okay. But though in alkanes we only have 2 hydrogens, so it is better to show in the other form like this. Okay. Now, the thing is how the pi bond is forming. Sigma overlap is head to head overlap. Yeah, you must have studied in the previous classes, head to head overlap. Now, the pi bond, there is one pi bond also. C double bond C contains 1 sigma and 1 pi bond. So, this is the formation of a sigma bond. How the pi bond is formed? See, there are 2 hydrogens formed by the sigma overlaps, and there is one hydrogen. There is one. This is a sigma bond formed by the. This is a sigma bond, head to head overlap, right? Now, how the pi bond is formed? There is another p orbital it has. Okay, so these lobes interact with each other, and this gives a pi bond. How it is? See, this can also be shown like this. This forms a pi cloud. That doesn't mean that these are two different bonds. This is just a sideways overlap. Pi bond is a sideways overlap. So what structure in the end we got? So these are the formation, these were the pi clouds, and this will give the structure as C, single bond C, H, H, and there will be a pi bond. So this is a pi bond and this is sigma bond. How these two are different? Sigma bond is head to head overlap, pi bond is sideways overlap, of the orbitals. Okay, so if as there is head to head overlap, it is a stronger bond. Comparatively, pi bond is a weaker bond than a sigma bond. And how we can distinguish this is how the pi bond is weak, how the sigma bond is weak. We can see the bond energies of the pi bond and sigma bond. Bond energy, as I have already discussed in the previous class, that is the energy required to break the bond or form the bond. So sigma bond energy, I have discussed in the previous class, it's 350 kilojoule per mole around, whereas the pi bond strength is around 280 kilojoule per mole. So it's clearly visible that this sigma bond energy is much higher than the pi bond energy. So that the sigma bond is stronger than the pi bond. What else do we first need? Just keep a note in the mind that pi bond formation will occur only after the sigma bond. And why it is so? The reason is that pi bonds or sigma bonds are stronger than pi bond. And as the rule of nature states, obviously the stronger things will form more earlier than the formation of the weaker things. That's why sigma bonds form earlier than the pi bonds. After pi bond formation will only be followed by after the formation of the sigma bond. Okay, this was the structure you must. Okay, so we have discussed about the structure of these things. Let's talk about a few properties of the alkene molecules. Okay, properties. So there is one sigma and one pi bond involved. Okay, the second property we can say, let's suppose the bond energies. pi bonds are weaker than sigma bonds. I have already mentioned the bond energies of these. Third, let's talk about the general formula. Alkane has a general formula of CnHn plus 2, but there is only a C single bond C, right? These have a general formula of CnHn CnHn. So this is a general formula of alkenes. It can n can be starting from 2, 3, 4, 5. Remember, n can't be 1 here. So this is a C2H4. One thing, okay, it's a 2n. Okay, there is other is C3H6, C4H8, so on. The structures will form. Okay. Fourth, what we can say is the bond lengths. C single bond C and C double bond C. C single bond C, I have already mentioned in the previous class also. It's about 154 picometer. C single bond C has a bond strength of 154 picometer, whereas C double bond C is 134 picometer. Okay, let's now about the bond angles. So the bond angles between this thing H and C double bond C is 121.7 degree, and the bond angle between this HC and H, it is 116.6 degree. Okay, so these are the bond angles. Bond energies I have already told: sigma bond, pi bond, homologous. Okay, as I have discussed that alkane form a homologous series. Alkenes do also form a homologous series. How? The first molecule is C2H4, right? Then is C3H6, C4H8, C5H10. Okay. So there is an increment of plus 1 C and 2 hydrogens. Again, there is an increment of 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens. So same as in alkanes, it also forms an homologous series where there is an increment of a CH2 unit between the successive members of the alkene group. Okay. So in this chapter we have till now discussed about the alkenes, what alkenes are, how the structure looks like, what are the basic properties of the alkenes. And else we have discussed about a bit more about aromatic compounds. What aromatic is a special class of hydrocarbons containing a pi sigma localization, delocalization in the entire ring. Do remember about the entire ring. The conjugation will be in the entire ring, not in the portion of the ring. So now in the next classes we will going to discuss about the alkynes, a bit more about alkynes, and in detail we will study about the properties, how the alkanes behave, what are their chemical properties or physical properties, how they look like, how alkenes looks, how their properties are different among the members. So this we will going to discuss in the next class. Thank you so much.